Hello, this is Mr. Stansbury. I'm going to take you through the notes on chi-squared test for independence. At the end of this, you should be able to say, I can use the chi-squared test to determine if two variables from the same sample are independent. Okay, so the chi-squared test tells you if two variables are related or impact each other. For example, gender and income, do those two have an impact on each other? Year in school and visits to Starbucks, does one impact the other? Favorite movie genre and favorite snack, does one have an effect on the other? Okay, so it's testing for their independence or dependence. Okay, so the steps to doing that are these 7 steps here. Okay, so we're going to state the null hypothesis just like normal, and the alternate hypothesis, and it even kind of tells you exactly what to write there. Significance level, degrees of freedom, which is a little different with this, but we'll show you how what the difference is. Construct the expected frequency table and calculate the value of the chi-squared test. So I'm going to show you how to do expected frequency table by hand, and also your graphing calculator will do it for you as well. Use technology to calculate the p-value we've done, and then reject or accept HO and interpret your decision. So again, very similar to what we've been doing. Okay, so let's do this. Let's take a look. Oops, not at that, but at this. An example says the table shows the results of a sample of 400 randomly selected adults classified according to gender and regular exercise. Are gender and regular exercise dependent on each other? Okay, so this chi-square test is really kind of a nice one, especially this test for independence is a really kind of fairly interesting one, because it just tells you, it's like, does one thing have any kind of impact on the amount of one, have an impact on the amount of the other? Okay, so this is what we call a 2x2 contingency table, and this will make a little bit more sense when we get it further in here, but just wanted to point it out right off the bat. We have two things. We have regular exercise or no regular exercise, and then male and female. The sum column and row are not considered in the contingency table. So this has got 2 rows by 2 columns of data. Okay, so here's our chi-squared test for independence steps again. So we are going to cruise through and do some of these. Actually, we're going to do all of this, but anyway, state the null hypothesis and alternative hypothesis. So it's nice because they even tell you what to do. So HO, the variables are independent. So our HO will be gender and exercise. Let's even do regular exercise are independent. Gender and regular exercise are independent of each other. So that means H1 is going to be that gender and regular exercise are dependent on each other. Okay, so there's our step 1. Okay, state the significance level. Didn't state one up here, so let's just say our significance level, a very common one, is 5%. So we would write that as 0.05 is our significance level. Okay, our degrees of freedom is going to be our rows minus 1 times the columns minus 1. Okay, so in this case here we have 2 rows across, you row across a lake, and columns are vertical things that hold up a building, so that's up and down. So in this case, our rows are 2, our columns are 2. 2 minus 1 is 1. 2 minus 1 is 1. 1 times 1 gives us 1 here. So our degrees of freedom in this case are going to be 1. Okay. Now, step 4, construct the expected frequency table and calculate the value of the test statistic. I'm not going to require you to do the expected frequency table by hand, but I have seen that many times on an IB test. So I'm going to show you just really briefly how you would want to do expected frequency table by hand. So what you're going to do on this is we're going to take here, let's get our data back up. Here's our data. So to do our expected values for each of these, we got to find one for each of the four cells here. So to find the expected value for regular exercise of male is what you're going to do is you're going to multiply the total in regular exercise, 208, by the total in male. So the total in this row and in this column, right? So 208 by 216, 216 by 208, and then you're going to divide by the total of each of the row and the column. They should always add up to be the same. So we do 216 times 208 divided by 400. This expected value up here should be 112.32. To find this one here, it's going to be 216 by 192. 216 by 192, always dividing by this 400 over here. Divide by 400 gives us that. This one down here, female regular exercise, is this cell right here. So that's going to be 208 by 184. There's our 208 by 184 divided by 400. And then this one over here is 184 by 192 divided by 400. And these give you your expected values. And that's how you do it by hand. The graphing calculator will actually go through and calculate these for you. And I'll show you that how that comes about here in a second. Okay, so we basically showed you how to do that. Now, I'll show you also on the graphing calculator. Use technology to calculate the p-value. So we'll do that on the graphing calculator. Find the critical value for the test. So that's where we got to use our critical value table from page 403. So the key thing that we know is degrees of freedom is 1, and we're doing it at 5%. Okay, so we got to pull that back up. Have to get the rest of the stuff out of the way so we can find that. So degrees of freedom on this thing, remember we said that is 1, and we're going to a 5% level of significance, so they meet at 3.84. Okay, so our chi-squared critical value is 3.84. So when we write our inequality here, we've got the critical value, 3.84, and then our chi-squared calculated, what we're going to do on the graphing calculator is going to be the other part of this inequality. Okay, so let's get that in here. Now, to do this here, we are actually going to go in and we are going to do this in a matrix. So what you want to do for this is do second matrix. And then it's always rows by column. So there's 2 rows by 2 columns. That makes it pretty easy. We only need to worry about the first one here. So we're going to go over to edit, and we're going to edit number 1. And we want this to be a 2 by 2. Good news is if you mess up the numbers, if you get them backwards, it will give you the wrong dimensions here on this. So you can always go back and switch it. Okay, so now we're going to, again, only enter the stuff in the red box, never the sums part, just the raw data. So we're going to enter that data in here, 110, 106, 98, and 86. Okay, so that gives us all of our data. Go into stat, and again, back over to test, because all the stuff we're doing in here is test, and this is the chi-squared test for independence. So there's, if you remember from before, there's 2 little chi-squared. There's the goodness of fit test, which we've used a bunch. Now we're going to use just the plain old chi-squared test. Okay, so we push enter, and our observed data is what we put in A. It's actually going to calculate our expected value here in B for us. I'll show you that here in a second. But we go through and we push calculate, and it gives us our chi-squared value is 0.217. So let's see, chi-squared calculated 0.217. So that's going to go over here, 0.217. And our p-value is 0.641, right? Because I think it's somewhere in here it said to find, there it is, 0.641 is our p-value, and this is our chi-squared calculated value. Okay, So with that, we have this inequality. So we're going to just plug that in, which we did. And let's see, 0.217 is not greater than or equal to 3.84. So this is false. So reject it if this is true. So we are not going to reject it. So that we officially don't reject HO, which means accept HO. So accept HO, which means that gender and regular exercise are independent of each other. Okay? Gender and regular exercise are independent of each other. Okay? All right. That's all we have for chi-squared test for independence. If you have any further questions, please feel free to ask in class. Thanks.